on interpersonal behavioral and neural synchronization. Thank you, Kohei.
Thank you so much. Good afternoon. Thank you for being here. Many people may be leaving to my country now for ICMPC, I think. And then thank you for organizers for this wonderful workshop. I'm really happy to be here. So today I'd like to talk about our recent project on interpersonal entrainment using hyperscanning fMRI. So as you already know, so people spontaneously synchronize their movement with their co-actor when they interact visually and auditorily. So automatic imitation of movement can be seen at an early stage of development. Another familiar example is synchronization by clapping and walking. Various experiment tasks also show synchronization in the laboratory. I'm interested in this neural mechanism of this interpersonal synchronization. So what we have learned so far is that synchronization occurs by watching or listening to the other person's movement, even without intention to synchronize. And a mirror system, that's a shared action representation of self and another, is involved in, and such as superior temporal gyrus and inferior frontal gyrus, and then inferior parietal lobule. It has also been demonstrated that there is a close relationship between the synchronization and the social closeness. Interpersonal familiarity boosts the strength of interpersonal synchronization. So if paired participants know each other like a friend, they tended to show more synchronization than other pairs. On the other hand, synchronization and mutual imitation or imitative interaction can induce prosocial behavior and a sense of familiarity with the partner. So there's a close relationship between the interpersonal synchronization and the social closeness. So the aim of the current study is to reveal the neural underpinning of interpersonal synchronization. So we hypothesized that imitative interaction increased the familiarity and occurrence of interpersonal synchronization. And the neural synchronization in the mirror system is involved in this increase. So to test this hypothesis, we use the hyperscanning fMRI method. So participants were 58 healthy volunteers, so 29 pairs. They were not mutually acquainted prior to the start of experiment. We used 2 MRI scanners with double video system that enables participants to engage online interaction of hand movement. In this task, participants were asked to draw a circle in the air, and then an MRI-compatible camera recorded the participants' hand movement. The image was horizontally flipped and projected on the screen in the other scanner so that paired participants could see each other's finger movement. As an imitative interaction, we use imitation of writing. I'm not going to show this data today, but we are interested in 2 factors which are shared during imitation. Prior imitation, what to do, and also the action intention, how to do it. So we asked the participant to write 2 characters of Japanese katakana, which do not have any meaning. So as the instruction initiator was just asked to write 2 characters in all conditions, and then a responder followed or unfollowed the initiator's action with shared prior intention or without. Under 4 combination of conditions. So all pairs of participants performed this imitation task with all 4 conditions. And then before and then after this imitation task, participants answered the inclusion of other in the self-scale IOS and also performed the circle task. So in this circle task, participants were instructed to draw a circle in the air with their right index finger. while seeing the partner's finger movement for 6 minutes. And then as a cover story, so we explained this task was to test basic motor function, like spatial temporal accuracy and endurance of neuromuscular system. They were not explicitly instructed to synchronize with each other. Just they are asked to keep watching the videos and to do their best to draw a circle as accurate and stable as possible at their preferred frequency. But it should be the constant speed during our session. Then we track the finger tip using deep lab cut and calculate the relative phase angle based on the time point of positive peaks in the x-axis. So here's the behavioral results. The iOS significantly increased in the post-session, suggesting participants felt more familiarity with the partner after the imitation task. However, there was no significant difference in the relative phase angles of the circle task. This histogram showed the absolute relative phase angles of all pairs. And then these figures shows a scatter plot of mean and the standard deviation of relative phase angles between the pre-session and the post-session. So both shows significant positive correlation. So next, we calculate the difference by subtracting the values of pre-session data from the post-session data. So the negative values indicate that it decreased after the imitation task. So as you can see, some pairs shows decreased values, but not many. So basically, we did not find a significant effect of imitative interaction on interpersonal coordination. Sorry, synchronization, I should have said that. Yes. So for the Interbrain analysis, we performed voxel-wise correlation analysis, in which cross-correlation was performed between the voxels at the same coordinate between individuals. So, and then we performed the same analysis with pseudo pairs and compared with that between the real pairs and pseudo pairs. As a result, excuse me, in the pre-session, there was an interbrain synchronization in the right superior temporal gyrus and then premotor cortex. In addition to these areas, in the post-session, the left middle temporal gyrus are synchronized. This the right superior temporal gyrus was overlapped between two sessions, and then also the premotor cortex also shows it was really close between two sessions. So in this analysis, we found interbrain correlation, at these areas, but in this analysis, we did not see the relationship between the different regions. So this is because of the computational resource problem and then multiple comparison issues. So, but to explore the interbrain and the intrabrain network related to behavioral synchronization, we recently performed the connectome-based predictive modeling. So to perform this CPM, we made a connectivity matrix between brain regions. So to reduce computational demand, we use a Shen 368 persuasion. So time series were averaged across voxels within each regions of interest before creating connectivity matrix. And then calculate correlation each edge in the matrix with the behavioral measure. So here we use the standard deviation of relative phase angles because it's stable index of synchronization. Then select the most significant correlated edges. Using selected edges, make a model to predict the behavioral data. So the idea is not performing a multiple comparison for each edges. It's the edges were judged with the prediction accuracy of the behavioral data. So we extended this SIP connector-based predictive modeling to the Interbrain analysis. Then regarding with model training, we have 2 sessions. So we train the model using the pre-session data and then test it with the post-session data, and then vice versa. This is preliminary results, but this graph shows the high interpersonal synchronization network. Blue line indicates the intrabrain network, and the red line shows an interbrain network. So node sizes indicate the number of connection with other nodes. I did not fully interpret the results yet, but the interbrain network was apparent in the left hemisphere, and the left dorsal prefrontal cortex might be the hub of this network. As a possible hub between the intra and the interbrain network, the right, the right superior parietal lobe has a rich connection with nodes within and between the brains. So, as a summary, imitative interaction increases the familiarity, but not interpersonal synchronization. So our imitation task includes some no-imitation condition. So it's not purely imitative interaction. That might affect our results. And then the second point, interbrain synchronization was observed in the right STG, superior temporal gyrus, and the premotor cortex during online interaction. This result is consistent with previous study, which shows interbrain synchronization in the right temporal parietal junction, TPJ, and then this area can be part of this TPJ. Lastly, connectome-based predictive model can be useful too to understand the intra and the interbrain network for interpersonal synchronization. I would like to thank all of my collaborators in this study. Thank you for your attention.
Thank you so much, Kohei. Are there any questions already from the audience?
Given that this task didn't change interpersonal synchronization,
yes.
Do you have ideas as to what task might make a difference in that in a sort of a pre-post test?
Excuse me.
What do you think would happen if there were a change in interpersonal synchronization?
What change?
If I understand correctly, there was the task that you gave, one of the hopes was that there would be a change in interpersonal synchronization.
Yes.
And that did not happen in this case. What is a task that might change that, and what would be the implications?
So maybe, I don't know. It's the one problem. So the difference between this study and with the previous study is like it's not face-to-face. So basically, the imitation writing, they cannot see each other's face. Of course, during the explanation, instruction of the experiment, they see each other's. But after they went to the scanners, they never see each other. It's just hand. That's it. It might affect the results. And then also, our task is not purely the imitation task. Sometimes they do different things. This can affect the results, but not sure. And then I think previous studies focusing on the effect of such imitative interaction. So the task is not so long that much. So in this case, they engaged imitation task for around 1 hour. And then after that, they do this synchronization task. That's going to be problem, maybe. So yeah, that's my ideas.
how would you think it would, or like, do you expect that the results might differ if you had a task that was more like discrete movement rather than continuous, and then also with the intention to synchronize versus not intention to synchronize? Is there any literature already, or do you plan on following it up with like varying the task characteristics?
I didn't characterize the reader or follower relationship, but if they perform this task intentionally, I have no idea.
It's hard to say, right? Sorry. Terrible question, but I guess it's more,
Yeah,
are you planning on pursuing that, or what's the next step for you?
Yeah, so thanks. The results, it clearly shows that the interbrain synchronization at a specific sport, right? So it's easy to deactivate the brain regions with like TMS or something. So if I want to see the causal relationship with this data and then behavioral data.
Yeah, super cool. Thank you so much. Are there any final questions? All right, another round of applause, please,
Thank
for
you so
Kohei.
much.
Thank you so much.